We are going to be looking at curve sketching in this video, and I'm guessing this is probably going to be one of the most highly watched videos because curve sketching tends to be one of the trickiest things to do. So when I'm looking at these curve sketching, it's really important to note that as long as you have a few key features, then it really is okay if everything else is not perfect. So let's get started on this, and just feel free to stop, pause, rewind, do all the things as you go to ensure that you're getting this down. What are the critical values of f? So critical values, our graph here, it's very important to first note what we're even looking at, and we're looking at f prime. So remember, this right here is where f prime of x equals 0. So our critical values are going to be -3, 0, and 2. We are increasing. This is where f prime is greater than 0. So this is going to be -infinity to -3, union 0 to 2. Oh, union 0 to infinity. There we go. Well, I guess we're technically not increasing. We could say this a few different ways. You can give that a 0 to 2, union 2 to infinity, because technically at 2 my slope is 0, but if you said 0 to infinity, that would also be okay. For what value of x does f have a relative extrema? That means that we are changing from positive to negative or negative to positive. So remember, minimum is negative to positive. So we have a min at x equals 0. Maximum is positive to negative. So we have a max at x equals -3. We are concave down. This right here will be f prime of x is decreasing. D-E-C. I can't spell. It's fine. Okay, so we are decreasing when that slope is negative. That will be from -infinity to -2, union. This is a really hard guy. I think I said 0.8 when I made the answer key, so let's just keep that. So let's say 0.8 to 2. Estimate the values where f has a point of inflection. So that would be like, where does it actually change? So these are kind of like the mins and maxes of this function. So I'm going to call this, so this is like f prime of x equals 0. These guys right here would be, let's call this at x equals -2, probably that 0.8 value, and then that +2. Using a red colored pencil, f of 0 is 0, so we know we have to pass through that point. Whenever it gives us a point, this is something we have to make sure we're going through. We're going to sketch f of x. So some things I know are that we have some, let's see, we need to get our maximums and minimums first. So we have a minimum at x equals 0, and we know it's going to be passing through here. So this is going to be a minimum, and we know we have a maximum at -3. We also know that we're increasing from -infinity to -3, and then we're decreasing from 0 to 2. So I'm going to go ahead and sketch that. Increasing, decreasing. Since this is hitting a minimum, I'm going to be moving up from there, but let's look at what's happening with our information. Our concavity kind of gives us a better idea. We're concave down from -infinity to -2. That made sense. That was our point of inflection. And then from 0.8, so we're going to be concave up until about 0.8 to, then we go to concave down. There we go. Sorry about that. I also know that I have an additional point of inflection at 2. So I know I'm going to be concave down, and then I'm changing to concave up at 2. So we're concave down for a hot minute, and then we're changing back to concave up. It's also important to note that the derivative is positive, so that means my slope should stay positive. I hit a brief point where my slope is 0, but then I'm still increasing because my derivative is positive. So when you are doing this, it is like super important. You might want to go re-watch that part again. I'll go through it one more time just to make sure we're like feeling comfortable there. When I'm doing this, the first thing I would do is I would say, all right, we have a max here. And maybe give yourself a point for a max. I know that we are also positive, so we should be increasing up to that max. And then we're negative, and we're decreasing all the way to 0. So we're decreasing all the way to 0. I'm positive for a hot minute, so we're increasing. Then I hit a flat slope, and then I keep on increasing. So we get a good general idea of what's happening, right, just by drawing these little arrows with what the derivative is doing. But then I kind of like fill in the blanks a little bit and make it a little bit more smooth with that concavity piece. So again, you're saying, okay, we're concave down until let's draw in those point of inflections. So it looks like -2 is where we change concavity. It looks like about at this like what, 0.8 mark is where we change concavity. And then it also looks like we change concavity again at this place. So we are going concave down, we're decreasing, then we are concave up, then we are concave down, then again we are concave up. So it's just kind of starting to like, you're just kind of coloring in the information that you're already given. Let's get this next guy done. f(x) is blue. So let's look at double. This is really just asking us to graph that double derivative, and this one has a few less rules because we cannot make as many inferences about this double derivative. All we really know is that the double derivative depends on that slope. So we know that that slope is 0 at -2. We know that that slope is 0 at, what, that 0.8 part? And also at that +2. We are decreasing from -infinity into that -2, so we are negative. We're below the x-axis. We are increasing up to that 0.8, so we're above. We're decreasing down to that +2, so we're again below, and then we are increasing. For the double derivative, these points are going to be kind of the best we get. So I'm just going to kind of go through here, and I would just give a general idea of what that looks like here. So I'm going to come in, and let's do it on our original graph. So we are positive, so we're increasing. Or sorry, we have negative slope, so we're negative until -2. Then we have positive slope, so we are above the axis till we get to this guy right here. Then at that 0.8, we're going below. And then at that +2, we're back to being positive. The only adjustment when I go back and kind of look at this and I'm like, okay, should I have adjusted this any? It looks like that maximum slope is obtained right here about at -1. So I might want to adjust this a little bit to make that maximum slope a little bit more apparent at that -1. But that's really all I would do. Let's check this out again on a different function. Sketch the graph of a function and have the indicated characteristics on the domain -8 to 8. Continuous and differentiable for all real numbers. Great. At this point, I'm going to go ahead and do some coding on my graph. I know that some of you might like to make a table with this information, and that is totally up to you. f of x is greater than 0 from -1 to 2. So from -1 to 2, I'm increasing. Also from 4 to infinity. We are less than 0, which means I'm decreasing from -infinity to -1, and then also from 2 to 4. So this kind of starts giving me a good idea. I'm like, all right, my graph is going to dip down something like this. Look kind of like a U or a W almost. And then I have some good information about concavity. I know that f double prime is greater than 0, so we are concave up from negative infinity all the way to 1. So here's kind of like my POI, right? We're negative infinity all the way to 1. We are concave down from 1 to 3. And then we're concave up from 3 to infinity. So here's kind of my we know that we have some POIs here, or point of inflections. Last thing I'm going to do is identify where these like mins and maxes are. So it looks like f prime of 1, f prime of 2, f prime of 4 all equal 0. So I'm going to get those kind of like written down, or negative 1. We know that there's going to be a min here. We know that there is going to be a max here. And I also know that there is going to be a minimum at 4. I am not given, let's see, am I given any ordered pairs at all? It does not look like I'm given any ordered pairs, so as long as you have this general shape, you are good to go. I'm just going to come in here and give it a good old sketch. So we are decreasing, then we hit that negative 1, we're increasing, we change concavity here, we have a maximum. So we're going to change concavity, maximum, we're going to change concavity again, have a minimum, and go up. So there's my min, there's my max, and we should be looking something like that. And remember, it does not have to be perfect, but you do need to meet those criteria where those point of inflections, it should be changing concavity at positive 1 and positive 3. There should be a maximum at positive 2, and there should be minimums at negative 1 and positive 4. Very last but not least, the graph of the derivative f is shown in the figure below. Sketch the graph of f of x. So here is my f prime. Remember that derivatives tell you the slope. So right here, this is a slope of 2. So it does not really matter what happens or where your line segment starts or stops, but you do need to have a slope of 2. So I'm going to use a point negative 1, 1, and I'm going to go down over 1, and then get that slope of 2. Next guy right here, we have a slope of 0, so it has to have a flat point, and I'm just going to go through the point 0, 0. Then we have a negative slope and positive slope. This is going to probably be a parabola because this is linear. So some sort of parabola. And then we have a flat slope of positive 2 from there. Any iteration of these line segments is going to work for you. So we're going to up 2 over 1, m equals 2, right? So we're going up 2 over 1, and I'm getting that slope here. So any sort of iteration or transformation of these line segments should work out. And check that answer key because I think there's a little bit more colorful in depth. I can pull that up here actually. Here we are. We have that slope of 2. We have that parabola. We have to hit that slope of 0, negative slope and positive slope. And then we also have a consistent positive slope of 2 on that other side. So as long as we have any iteration of these 3 line segments, I have no idea what points they go through, but we just need to meet those criteria.